All right, so this question we're going to do is page 143, number 8. So let's just look at it in our textbook. What they have here is 3 points. Now remember, we know that they're points because they have a capital letter and there's no equal signs or anything like that. So the 3 points, which I've labeled in the picture, are there. And they are 3 vertices of a parallelogram. So we only have 3 of the 4 points or corners of the parallelogram. So the first question says, find the coordinate of C. So we're going to try and find where coordinate C is. Okay. Now, the reason we can do this is because we know it's a parallelogram. Now, first thing I'm going to point out, this is parallelogram ABCD. The way in which we label parallelograms is very important. So this is parallelogram ABCD. When you label a parallelogram, in fact, any polygon, you label them by going around the outside edges of the parallelogram. Okay? It doesn't matter which order you go in, but often counterclockwise seems to be a popular one. I don't want to say it's a standard one, but it seems to be what a lot of people will do. So when I've drawn my parallelogram, and remember, just like yesterday, I can't draw this parallelogram for real because this is a 3-dimensional parallelogram in 3 space. So too difficult to imagine what it would look like, but it's fine. I'm just representing it. And like yesterday's drawing, remember, I may or may not have a good picture. Remember the one we said actually probably should have had 2 of them reversed when we were doing that triangle, but it didn't matter. The point was to give us some reference so we can organize our thinking. But in this case, I've drawn just a random parallelogram, but notice that I've gone A, B, C, D around the outside edges. I could have gone this way, A, B, C, D, and that would be as acceptable as well. What I can't do is do this, A, B, C, D, right? Because that, if you actually follow the letters, if you go A, B, C, D, that doesn't make a parallelogram. And the order that is written here will suggest all the sides of the vector, of the parallelogram. So any 2 letters that are next to each other should be a side. So you see how AB is a side, BC is a side, CD is a side, and then you can even wrap around and say AD or DA is a side. If we wrote it like this, BC is not a side, right? So you have to go around like this. Well, I guess all the way around like this, or the other way. Don't go A, B, and then cross over to C, D for labeling purposes. Okay? All right. So in this first example, I've drawn the picture for you so you knew exactly that information. What we now have to figure out is where is coordinate C? So any thoughts or ideas on how I could get coordinate C? Yeah.
Find B through the coordinates of A and D, use then B to solve for C. Okay.
So Liam's suggesting if we figure out this vector, is that vector not exactly the same as this vector? And so if we know what the vector is, we can maybe figure out what the other endpoint would be. So let's do that. So I'm going to go start by this and say vector AD is equal to vector BC. Be careful of your labeling here, because is AD the same as CB? No, same there. They're the same length, which is helpful, but they're not the same direction. We need two that are the exact same in order to make this true. Okay? So we're going to use that fact to solve this. The other thing I'm going to do is I know that the answer for C is some coordinate, some X, some Y, some Z. So I'm going to say, I don't know what it is, but right now I'm going to just call it X, Y, Z. Now, how do I find the vector AD? Remember, from day one, when we're finding vectors, if this is the vector you're finding, starting at A, going to D, you take where you are now, subtract where you began. So D minus A. And how about the other side? BC is C minus B. Now, in DA, I think we could actually do that math. We're just subtracting, so we subtract the X's, the Y's, and the Z's. So 4 minus 2 is?
6.
Yep. -3 minus 1?
-4.
And 1 minus 3?
-2.
So there's the vector AD. And I know it's going to be equal to the vector BC. To find that one, I'm still going to do the same subtraction, except I just don't know what the X and the Y and the Z are. But I know it's C minus B. So it'd be X minus 6, which is the same as X plus 6, right? Y minus 4. And then Z minus 0. Following along so far? Nice. Now, in order for these two vectors to be equal, all the components must be exactly the same. So the X component must be the same in both the Y component and the Z component. So that means that this must be equal to that. So 6 must be equal to X plus 6. What does X have to be in order for that to be true? Yeah. You can do a little subtract 6 from both sides. X equals 0. What's Y have to be? Sorry?
It has to be -4 on the other side, so you have to do, it would have to be 0 again.
Yep. Good. And then what would Z have to be? Yep. So therefore, the point, negative. Point C must be at 0, 0, -2. Yep.
Wouldn't it be easier to add B to D minus A?
Yeah, okay. I don't know if that, I get what you're doing because you're like rearranging this little formula first and then do the D minus A and then add B. Yep. Yep. That's just, I guess, 3 steps, but 3 additions, but maybe it's less than what I'm doing here. Yep, that's neat. That's a good idea. Good. Yeah.
Instead of doing that, could like just going through it and doing it in a whole, like separate parts, could you not just take your D minus A and add it to B?
That's exactly what Jesse
okay.
said. Yeah. No, but you're right. You could definitely do
Sorry.
that. Yeah, absolutely.
I'm hearing things different.
No. It's good. I've had people suggest that before, and not 2 people, so that's good.
But one right after the other.
Yeah, I know, yeah. Does anyone else have any questions they want to maybe ask or?
What about addition?
Yeah, thanks. All right, so yes, absolutely, you could do that. I just like this visual of it in that I know how I calculated AD by doing subtraction. So I'm going to do the same in the other one, and then it logically to me makes sense this way. Okay, good. So that's the first part. That's just A. There's lots we can do with this parallelogram now. Find the measure of the interior angles at the parallelogram to the nearest degree. So what that means, let's pick, I don't know, this angle here. It says find that angle. Now, are we all good that if we find one of them, the other one's pretty obvious, right? That's a parallelogram, so you do 180 minus the other one. So let's just find that guy. So how do I find angles in parallelograms? Any ideas in this guy? Yep.
Well, if you convert side lengths to vectors.
Yep.
And then use the dot rule.
Yep, what we just did, right? Finding the angle in between. Perfect. So let's do that. So Jesse's suggesting, and I'm sure someone else will suggest in a second.
Time. Guys, stop. It's a low moment for me.
That's good.
It's really early. Okay. I do this every day.
What Jesse's suggesting is let's put these side lengths as vectors and then use our little formula to figure out the angle between them. Okay? So I'll just call this one U and this one V. So U, I'm doing question B over here. U is BA. Do you agree? Is the order important?
Yeah, they have to start together.
That's right. If we're going to find the angle between them, we have to put their beginnings together, tips together, or tails.
No.
It goes tail to tip. Yeah, that never makes sense to me, but I'm going to say beginning.
Tail.
Oh, tip to tail. Yeah, I guess like
Yeah.
nose of a dog to the tail.
Yeah, tail.
Sure. Okay. Regardless, we got to have the beginnings together. So we're going to do BA, which is, of course, A minus B. I don't think we figured that out in the other one. So let's just do it right now. What is A minus B? Actually, do it in your head first.
Take your time. Well, I gotta figure out what we did the first time.
So subtract the X components, the Y components, and the Z components.
We're doing A and B.
We're doing, yeah, oh, sorry, A minus B. Anyone want to volunteer an answer?
No.
Yep.
4 negative 3.
4, negative 3, 3. People agree? Negative 2 minus 6, so that's like plus 6. 1 minus 4, negative 3, good. And then 3 minus 0 is 3, good. And let's do V. What is vector V with the letters given the endpoints?
BC.
Yep. Which means C minus B, right? We just figured out what C was. C was 0, 0, negative 2. So do that subtraction. So 0 minus 6, so that's a 6. 0 minus 4, and then negative 2 minus 0 is negative 2. You guys get that too?
Yep.
Okay, so now I have these two vectors positioned in the right spot. Now we have to find the angle between them. So this was one of the things we did in our warm-up. So cos theta equals u dot v over magnitude of u, magnitude of v. So I give you a couple minutes to do that on your own, a good little review of finding angles in between vectors.
That's not cool. That's
I got 46.6.
That's what I did.
Sure I haven't made any silly mistakes. Multiply 24, multiply that as 12, multiply this as -6, add them up. And then square root of the squares, 16, 9, and 9, 36, 16, and 4, add them up. Punch that in a calculator, 46.6. My picture is 46.6, look pretty good. That was a guess, right? Is there a chance that maybe I could have gotten like 140 or whatever here? Well, not in this picture, but
If you're parallelogram.
who, right, maybe I didn't draw the right parallelogram. Remember, this is a 3-dimensional parallelogram in 3 space, so maybe I could have been finding the other one. So don't panic if you got an answer of like 140 here. You thought the picture might look like this, turned out that it looked like this. You know what I mean? And you just found U and V like that. But how were you to know that unless you actually did the 3-dimensional drawing? Okay. So luckily our picture does match what we suggested. What is the other angle?
33.4.
And how'd you get that?
180 subtract 46.6.
Right. So well, 180 minus that is going to get that. So we could have just as likely have gotten 133 as the bigger angle and just saw that our picture was wrong, but luckily it worked out. Okay, what does C say? Find the measure of the angles between the diagonals and the oh wait, that's wrong. Is that right? Oh, I don't like that one. I'm making my own. Ah. So we're gonna do a new C. You guys do this all the time. You make up your own questions by writing down the wrong thing. You just make up your own questions. So I'm gonna make up my own. What's another thing I could ask about parallelograms? Sorry?
The area.
Yes. Whoa.
Awkward. I can't do this.
So I'm going to make up my own new C. I don't like that diagonal one. It's a good question, but mine's better.
Okay.
Mine looks a lot more like what's on the test.
Oh, I wonder why.
Or quiz.
That's so wild.
Yeah, I know. I took a moment to think
You know
about
what?
it.
As long as you show me how to do it, we're good.
So I've got this parallelogram. How am I going to find the area of it?
Base times height.
You guys love base time height. I love it.
U times V sine theta or cos theta. That's all I'm giving you.
Okay, well, you're on the right track. Yep.
Of the magnitude.
Yes, remember, if you take the cross product of the two vectors.
Didn't remember that on my test.
No, you did not. So remember that area.
This is theta. I've always said theta. I know it's theta. I know
No,
it's
it's
I know it's theta.
I'm just gonna let that slide. Come on now. It's her birthday.
No, you can't let that slide.
Okay, I know it's pronounced theta. I just say theta.
For what reason?
Because I want to. I
You
don't
probably
know.
say schedule too, don't you? If anyone says schedule, ask them if they learned that in shul.
Schedule.
What?
Schedule.
You're
gonna say sure. Shut up. Elementary.
Okay, easy. I promote a positive classroom environment in here.
Complete.
Okay, yeah, no, I said, we don't, that's joking, we're joking. Okay, back to the question, please. U, V, we already figured out what U and V were, right? It was up at the top there. What was U? 4, negative 3, 3. Thank you. And what's V? 6, negative 4, negative 2. Okay, that's just coming from above.
Page catches.
I'm all flustered with all the,
Yeah, it's not. Oh, you wrote the wrong thing. Why'd you do that?
6?
Yes.
Yeah. Thank you, I think. All right. So
I think base terms.
remember that the area of parallelogram is the cross product of the two vectors that make it up. So we've already set ourselves up by creating these vectors u and v so that we could find the angle between them, but now we'll take their cross product. So I'll give you a second to do their cross product. Again, great practice of doing cross products. So I just saw you do it up on the boards there. I saw you do it yesterday. I got confidence we can do it again.
Six from. Oh, no, what's wrong?
So do these multiply,
Oh my God,
subtract
no.
these.
This is the
multiply.
problem.
Yeah.
Make sure I wrote it down right.
Kansas back one. I said, stop it. We're fine. That's good. Sure. What are you waiting? Oh.
I got 18, 26, and 2. Let's get that. Good. So am I done now? I did the cross product. Right, because that just gives me a new vector. How long that vector is what the actual area is. So it is the magnitude of 18, 26, 2. And how do I find the magnitude?
Square root of the squares.
Square root of the squares. Sorry.
I'm trusting your number up there.
Oh, okay, good. Did anyone else get that number?
Yeah.
0.7?
So I think we're trusting everyone else's number too, so we feel good.
Is it not 0.9?
I don't know, I got 0.7.
Whoa. Hold on.
Whoa.
Oh,
So she starts
Good.
singing.
thank you. Justin Bieber.
Okay, so you're right. Okay.
Thanks. We just got Adelaine's approval, thank God.
Adelaide.
All right. What do you think of this question?
It's a classic
Long.
vector question.
So
Totally classic vector
on
question.
the test, are you gonna do like
Quiz.
first you do A? Oh, sorry everyone. The quiz. Are you do A as one question, B as another question, then C as another
Probably,
question? Okay.
probably. I could just give you the parallelogram and ask you to just find the area of it.
I like the steps.
So you'll have to do this part here, okay? But there's just lots I could ask about this, and the reason this is great is because look at all the stuff we have to do, right?
That's great.
This is day one type stuff. Finding the vectors is day one stuff. Angle between, that was day one stuff too. Or no, it wasn't. No. That was day two. Because we need dot product. Dot product was day 2. Angle between, day 2. What was day 3? Cross product. Boom. There we are. Magnitude is all in there. Like it's one question that does everything.
Sort of
Okay.
not, 'cause we've only done this for like 2-3 days.
I know. Okay, so here's one to do on your own.
How big is this quiz?
It's only a couple of questions.
I don't really
Stop.
Like here's one.
Oh my goodness gracious.
Okay, the answers to this are in the notes. So I'm going to stop the recording now. Thank you, class. Everyone want to say thanks?
Thanks.
Thanks.
Already stopped it.
You want to say hi to who's not here? Paige. Shout out to Paige.
Hey.
Shout out to Crystal. Shout out to Ethan.
And the other classes watching in previous years.
Anyone else want to say hi to Ethan? Oh, there we go. Good.